So our first question is asking us to simplify the algebraic fraction. Now we're just going to apply our skills of factorizing to this question. We can't cancel top and bottom when the terms are adding or subtracting each other. By changing them into the bracketed versions, we have our adds and our subtracts being put together with a multiplication, and that's what enables us to do the cancelling. So the first one, as you can see, is the difference of two squares. So we've got x plus 4, x minus 4, and then you're going to factorize the bottom using whatever method you have. You can see my method is all about multiplying the first and the last term to get the 24 and taking it from there. Simplify if you do expand up, and then you can see that our result, x minus 4 and 2x plus 3, has a matching term on the top. So we can cancel out our x minus 4s to give x plus 4 over 2x plus 3. Okay, so we haven't seen proof yet. We can expect to see it. This I would rate it a kind of round the middle. It's not super easy, but it isn't super tricky either. We're being asked to prove algebraically that the difference between the squares of two consecutive odd numbers is always a multiple of 8. So it's a mouthful and a half, lots going on. So we really want to just think about what we know. We're going to have to write odd numbers. We know that even numbers are 2n. Anything multiplied by 2 will be even. So to find an odd number, we could just add 1 or take 1. I avoid the take one wherever possible because negatives can often make things go wrong. So I'm going to use the 2n plus 1 for my odd number. And then I'm going to jump to and write 2n plus 3 so I get the next consecutive odd number. They're telling us it's the squares of these odd numbers. So we're going to square each expression and it's the difference. So we're going to take away. But the way that I've written it at the moment, I have the bigger of the two on the end. I mean, it would work if I left it there, but I don't want to because, again, I'm trying to think ahead and avoid any pesky negatives if possible. So I'm just going to switch those round. And then I'm going to expand. So again, just whatever method you have, crab's claw, foil, whatever you do, expand those brackets. So the first one will come out as 4n squared plus 12n plus 9. And the second one is coming out as 4n squared plus 4n plus 1. But please remember, we're going to subtract all of that expanded expression. And when you do that, you create the bracket needing to be multiplied through by that minus. It switches everything around. So we now have 4n squared take away 4n squared, which would have happened even if you missed the negative causing the switch. But the next step, 12n, will become take 4n, not plus. That will give us 8n, and then you've got 9 take 1, which is 8. So we can see that multiple of 8 now appearing. We don't want to leave it like that, though. We want to factorize it so that we end up with 8 and then n plus 1 in the bracket. And that really does show. It doesn't matter what the value of n is, whatever it is, it's going to create a number that gets multiplied by 8. Okay, so we have a quadratic sequence. First thing that we're going to do is look at those gaps. It's going up 2, 4, and 6. Look at those gaps, and we are going up in 2s. Always divide by 2, regardless of what that second step is. We've got just 1, which means we have n squared in our solution. So our sequence is 1, 3, 7, 13. N squared is in the solution, and n squared gives us the numbers 1, 4, 9, 16. Now we take them away, which will give us 0, minus 1, minus 2, minus 3. And we start working on that pattern, the pattern that creates. They are going down 1 each time, so it's minus n. Go in the opposite direction, takes you to positive 1, so plus 1 on the end. Put it together and you have got n squared minus n plus 1 as your answer. Okay, so our last question is quite a complicated looking indice question. What we're going to need to do is get the base number the same. So we've got 9, 27, and 3 at the moment. 3 is the smallest, and 9 and 27 can be written in powers of 3. So you've got 9 can be written as 3 squared, and 27 can be written as 3 cubed. So we're now going to rewrite the question with our new values. So we've got 3 squared raised to the power of minus a half equaling 3 cubed raised to the quarter divided by 3x plus 1. Now do the maths. The rule here, our indice rule, is to multiply the powers. So we've got 3 to the power of minus 1 equaling 3 to the 3/4 divided by 3x plus 1. And now we can kind of move away from the base and just consider our indice rule. Our indice rule is when you divide, you take them away. So we've got 3/4 take away all of x plus 1 equaling minus 1. Expand that bracket. And then you'll just start to rearrange that equation, get x on its own, and you will see that x is equal to 3/4. And that's it. So with that type of question, get those bases the same. Indice rules only work when the base numbers are the same. So you can't apply them unless you have that sorted out.